We're going to be talking about the periodic table, and in particular, we're going to be talking about the periodic trends, atomic radius, electronegativity, and ionization energy, and how we use the periodic table to interpret these trends. Now, you know you got it if you can do three things. First, be able to define these three new terms. Second, that you can explain the trends as we move down a group and across a period. And third, you can label the periodic table with arrows showing the direction of these trends. So, what is a periodic trend? Well, a periodic trend is just a pattern of properties that is present on the periodic table. And there are lots of these, but we're going to focus on three in particular for this lesson. The first one deals with the size of atoms, and we call this the atomic radius. The second two are electronic properties, and that's going to be the ionization energy and the electronegativity. And we'll go into more detail about what they are later on. But for now, I want to explain where these trends come from, what causes them. So these periodic trends are going to be due to the attraction between the protons in the nucleus and the electrons out in the electron cloud. Every electron is attracted to the nucleus, and there's two things that affect that attraction. One is how close the electron is to the nucleus. The closer the electron is to the nucleus, the stronger the attraction will be. The second is how large that nucleus is, or how many positive charges it has. The more positive charges a nucleus has, the stronger the attraction. And so, looking at these two things, we can compare the forces of attraction between electrons, and these forces of attraction are going to change these periodic trends. Let's take a look at three elements as examples. So we have hydrogen, helium, and lithium. And I'm using an arrow to show the force of attraction between the electrons and the nucleus. And the thicker the arrow is, the stronger the force of attraction. So here's hydrogen. It has one proton and one electron, and there's a force of attraction between the negative and the positive. Helium has two protons, so it will attract this electron with more force than hydrogen because this positive 2 is a larger positive charge, so it will generate more force of attraction to negative charges. Now, lithium has a positive 3, so it will generate more attraction to electrons that are in the first energy level. But the other thing is how far away the electron is, and electrons in energy levels further away actually have weaker forces of attraction. So lithium's outermost electron has a weaker force of attraction than even hydrogen with only its plus 1. Now, this is what we need to think about when we think about periodic trends. There are two directions that we can use to describe these periodic trends. Moving across a period, and that means being in a row and going across the row. And as I move across a row, the number of energy levels is staying the same, but the number of protons is increasing. And so moving across a row, there's going to be stronger forces as I go farther and farther to the right because there are more protons. Moving down a group, well, now the electrons are filling more energy levels. So the electrons are getting further away from the nucleus, and those outermost electrons will experience weaker forces of attraction to the nucleus. So we always have to remember that we can explain periodic trends across a period and down a group. So, quick summary of what we've said so far. Periodic trends are just patterns. We're going to look at three of them coming up: atomic radius, ionization energy, and electronegativity. These patterns are due to the forces of attraction between electrons and the nucleus. The force of attraction increases across a period due to there being more protons, and the force of attraction decreases down a group due to there being more energy levels and the electrons being further from the nucleus.